But today's session, more generally, is about CHP maintenance and replacement in the UK. So with many CHP plants now approaching 10 years in operation, the question of engine replacement is becoming an increasingly important issue. This session is going to explore what the rules are around this in the UK, as well as how to ensure plants are well maintained on a continual basis. This session is also important for new developments, including biomethane plants where CHP units will be used for on-site power needs to ensure new CHPs are efficient. We'll look at recent developments, consider when to replace, and the economies of maintenance. There'll also be an opportunity to ask some questions at the end, like Julia described earlier. So for our first presentation, I'll introduce David Ray, and I will switch off.
Good morning, everybody. I hope you can hear me okay. My name's David Ray. I'm Marketing Manager of CPL Activated Carbons based here in the UK. So the overall session is about maintenance and replacement of CHP, but an important aspect is also protection. So you can reduce your maintenance burden and your costs by actually protecting the engines. So that's what we're doing as the first presentation today. And some of the things I will talk about also apply to biomethane upgrading as well. So I've included that in the title too. So quick run through. So start by introducing my company, what we do in the biogas industry. For those who aren't familiar with commodity, which you can see on the right hand side there, what is activated carbon? Why is it special? What does it do? I'll briefly touch on some of the main applications. Obviously, we're here today to talk about biogas and biomethane, but carbon is used in many different hundreds of applications. It's just interesting to see how broad our industry is. An important aspect of our business is reactivation of spent carbon. So carbon is a filtration medium. Obviously, it gets used up, but when it is used, wherever possible, we will recycle that. And I'll briefly talk about the benefits of doing that. Another important aspect of our business is mobile carbon filters. So this gives you the flexibility to have any filtration solution you require to match your particular requirements. Then I'll talk a bit more specifically about biogas purification. So the selection of the correct carbons for your particular problem, and I'll try and elaborate with some case studies. So a little bit about my company, CPL Activated Carbons. We've been around for 30 years. We're a UK-based supplier of carbon products, but in addition to that, we also manufacture a number of our specialised grades, our impregnated carbons here in the UK. I'll talk a little bit about impregs a little bit later, what they do, what that means. As I mentioned before, wherever possible, we recycle our carbons, and we have a large plant here in the UK to reactivate carbon from what we call amber list waste. So that's industrial applications like biogas, odour control, remediation, wastewater, that type of thing. We produce a range of in-house mobile carbon filters. You can see 3 of our larger vessels on the right there, and they're produced in-house by a subsidiary of ours. And in addition to making the filters, we have full engineering capability in terms of design, manufacture and install. So if a customer hasn't used a carbon filter before, we can design the pipework, the connections, the flexible hoses, everything required as a one-stop shop to use activated carbon in your process. Here in the UK, we have a nationwide site support services. You can see one of our site support vans there. That's actually at a landfill biogas site here in England. Carbon's been around a long time, but it is a very technical business. So we have full R&D and QA lab support at our reactivation facility, so we can help customers with a particular issue if that's required. And as you would imagine, we have the latest environmental and quality accreditations. This idea of a full carbon and service, so carbon vessels and reactivation, it really depends on vessel service centres and waste transfer centres. We have those in the UK and in France. Plus we have the capability to operate in Spain. But speaking more globally, we can supply our primary product, activated carbon, anywhere in the world. So we can supply gold mines in Australia, we can supply petrochemicals in the Middle East. So we can supply carbon anywhere, but specifically for the full carbon and service with vessels and take back and regeneration, we would generally concentrate on Western Europe, UK, France, Spain. So what is activated carbon? Most of you, well, hopefully many of you will have heard of it. Basically, it's a very pure form of charcoal with a very high surface area. People typically say a teaspoon of activated carbon has a surface area of a football pitch. That gives you some indication of the surface area we're talking about. Raw materials are typically carbonaceous raw materials like bituminous coal, coconut shell, wood, and increasingly other types of biomass. Each of those raw materials gives a carbon with a different set of properties, and yeah, it's the job of the activated carbon supplier to help a customer choose the correct product for their particular purification situation. It comes in various physical forms. Granular, so it's, as the name applies, granular activated carbon, referred to as GAC. Powdered carbon, not used in biogas, but it's used in other applications. And extruded pellets, which again typically used in gas phase applications like biogas. So this vast internal pore structure I mentioned is basically lots of holes, as you can see in the micrograph on the right hand side. And it's those holes that basically trap the impurities in a gas or liquid phase stream. And the process is called adsorption with a D. It's different from absorption. The impurities are simply trapped on the surface and in the pores on the surface. And that's generally a reversible process. So that allows us to reactivate or recycle the carbon by putting it into a kiln at sort of 800, 900 degrees C. So that allows us to regenerate the carbon. And the impurities are desorbed. They're basically, destroyed from the surface, leaving a clean carbon, which can be used again and again. So obviously offers environmental benefits and economic benefits. So a standard carbon is ideal for organic impurities. You may be familiar with the term VOC, volatile organic compounds, and in biogas, particularly siloxanes are a big problem, certainly in landfill gas and sewage gas, and they're particularly damaging for CHP engines. But for other contaminants, inorganic compounds like hydrogen sulfide, ammonia, mercaptans, you can actually chemically alter the surface of the carbon. We call it impregnation. And you're promoting a different type of reaction on the surface. It's actually a chemical change rather than a simple adsorption, desorption. So basically for many, many different types of impurities, we can help you provide a carbon that will take those out and protect your CHP assets or help you purify your biomethane. As I mentioned, it's a well-established technology. It's been around a long time, but it's the goalposts are always changing, and that's why we have R&D and QA to help us develop new products and to assist customers with new solutions. So there are many hundreds of applications for carbon. I've read 600 distinct applications for carbon, but broadly speaking, the main groups are shown down the left-hand side here. So air treatment, so that could be odor control at a wastewater plant. It could be VOC abatement at a chemical factory, for example. Water treatment could be anything from drinking water, so that you turn a tap on, that drinking water has come through a carbon filter at some stage. It could be an industrial process water or some sort of wastewater or remediation type project. Biogas, so what we're interested in here today, and biomethane, of course, is an important and growing application for carbon. Flue gas, so this is your non-recyclable municipal waste. It's usually incinerated to recover the energy content. Carbon is used in the flue gas scrubber to take out mercury and dioxins and other impurities. It's used widely in the food industry as well. Sugar purification, edible oil, many other food applications, beverage as well, beverage purification, alcohol. And I mentioned briefly before, gold recovery is used widely in the gold industry to recover gold and other precious metals, plus many others. But I just wanted to give you a flavour for the types of industries that we supply. And there's many crossovers. For example, a biogas plant might have an odour control facility, and it may have a landfill site might have a leachate on the liquid side. So many crossovers, and we train our guys to go in and ask the right questions and work out where the carbon is needed. So what do we do at CPL Activated Carbons? Well, we obviously supply the product, the carbon itself, this black granular pellet or powder. But in addition to that, we supply on-site services to assist with the installation and removal, or it could be with carbon filters or the engineering side I mentioned before. Wherever possible, we take back the spent material back to our reactivation facility. You can see on the top right there, that's at Immingham on the east coast of England. And we call it our RegenSys service. And if you look at our website or our YouTube channel, you can find out more about what RegenSys service looks like. Occasionally, carbon cannot be recycled, so we will assist customers, advising them on waste handling and disposal. But as I say, wherever possible, carbon is always recycled. Just a brief slide on reactivation. So we have a large manufacturing capability here in the UK, again with QA and R&D labs. We have two completely separate spent carbon reactivation units. The big one is our 8,000 ton Amber list reactivation site. That's for industrial applications like biogas. You can see that's on the top right-hand side, and that's the big beast. That's in fact one of the biggest Amber reactivation facilities in the whole of Europe. We opened that just a couple of years ago. And in a totally separate building, we have what we call green list reactivation. So that's from drinking water and food. So as you can imagine, you need to keep those two streams completely separate. So we work with UK water companies recycling their activated carbon that's used for drinking water. So there are many advantages of recycling your carbon, both economic and environmental. Principally, carbon footprint. We've calculated the footprint saving of using recycled carbon rather than a brand new or virgin carbon is more than 90%. That's huge significance. There's no need for waste disposal or incineration because the carbon is reused again and again. And also it protects you from the carbon price fluctuations. So virgin carbon goes up and down. In fact, two global carbon companies have just this month have announced large price increases on their virgin carbon. So by recycling the carbon you already have, that protects you a bit from those fluctuations. But what about its performance? Well, for most applications, recycled carbon maintains excellent performance. And that's particularly true for siloxane removal from biogas, which I hope will be of interest to a number of you today. So a second aspect of our business, which is growing of importance, is our mobile carbon filter vessels. We call the family the CleanFlow range of filters. And as I say, we design, supply and rent those with our in-house production capability called CPL Icon, based here in the UK. We have a large and growing fleet, and the rental fleet ranges in size from 2 cubic meters right up to 30 cubic meters. You can see the 30 cubic meter vessel on the top right-hand side. That was designed specifically for the biogas industry, notably landfill biogas, but also used for biomethane sites as well. We have a reasonably high flow of quite heavily contaminated gas. So you need a deep bed filter of that size to give you the protection you require. We have vessels for liquid phase and for gas phase. So again, it could be wastewater, it could be leachate. On the gas phase, it could be odor control or biogas filtration. And we have some special versions available called high flow units. I'll show you briefly on the next slide. Not really used for biogas per se, but if you have a high flow odor control situation or a very high flow VOC contamination, you might want a high flow type filter. Of course, they're fully portable. They're delivered. You can move them around with forklift trucks, as you can see in the picture there. The large ones are delivered on a dedicated tipping trailer. So they're delivered to site and simple plug and play concept. So there's no on-site carbon handling. When the vessel is spent, we'll simply replace it with an identical unit. We'll take the vessel back for reactivation. And it's a modular concept. So you might start with one filter, but you might have a spike in contamination or an increase in gas flow. So you might want a second filter, and that could be in parallel or in series. We call a lead and lag arrangement. And we will advise you on the pros and cons of arrangement of multiple filters. And with our engineering capability, we can help you set up multiple carbon filtration solutions as well. And I'll show you an example of one of those later in a case study. Yeah, so I mentioned high flow units. So you can imagine a waste transfer station where they have to change the entire air volume in the building 3 times an hour. So it's very, very low contamination level, but very high volume. So we have these high flow units. Our flagship unit there is called the HF24, contains 24 cubic meters of carbon. It stands on a 30-foot container, so it's about 10 meters. It has twin carbon chambers that go down the entire length. So it ensures an even flow distribution of the gas through the carbon, but with minimal pressure drop. And that unit there can cope with flows of up to 45,000 cubes an hour. That's a very high flow. Again, it's typical for waste transfer stations. But on the biogas filters, it tends to be up to say 5 or 5,500 cubes an hour. So, a bit more going into more detail, I'll explain what we supply to the industry. So, what is CHP protection with carbon? Well, you need to remove impurities. So you're trying to protect the CHP or upgrade the biomethane. Broadly speaking, there are 2 types of compounds. You have your organic compounds, also known as VOCs, volatile organic compounds. Typically, these are things like siloxanes, which you find in municipal waste in landfills, and also in municipal waste in wastewater treatment plants. Pinenes, that's a compound you find in domestic cleaning products. limonene from citrus fruits and that type of thing. All these things are VOCs that you'll want to remove from the biogas. Siloxanes in particular are a problem in the biogas industry. It's basically a silica type, well, it deposits silica on hot surfaces. So basically inside your engine, it coats the engine with glass effectively, which can cause enormous damage and be very costly to replace or maintain. So by having a carbon filter up front, you can protect your assets in that way. So for these organic compounds, we generally recommend a standard carbon, a non-impregnated carbon. And these typically are either the pellets, the 4mm pellets are best known, or increasingly large granular. And on the right-hand side, you can see a picture of both types. In the foreground, you have a large granular type grade, and in the back, you have a more traditional pellet. There's no difference in performance from either, but the large granular tends to be a little bit cheaper because you don't have to process it into a pellet. So that's becoming increasingly common in gas phase applications. And the carbon can either be virgin or regenerated. As I say, wherever possible, we will take back and regenerate the carbon. So those are good for all your VOCs and your siloxanes in particular. But for your inorganic compounds, notably hydrogen sulfide, so any decomposing organic matter will generate H2S. If you're using chicken litter in your biogas, you might have ammonia problems too. It's quite a problem on agricultural sites. So for those compounds, you need an impregnated carbon. As I mentioned before, we treat our carbons with various chemical impregnants, depending on what you're trying to achieve, to allow you to remove those. Yeah, going back to H2S, yeah, H2S is toxic and corrosive, so you definitely want to take that out before it hits your engine or is released into the atmosphere. Now the choice, we have a very large range of impregnated carbons, and the choice depends on many things, including the oxygen levels, for example. People often don't realise that the process conditions are as important as the contaminants you're trying to remove. This is a big subject in itself. I'm doing a breakout session tomorrow where I go into much more detail on this. But the message is, please come and speak to us, speak to another carbon company, speak to the experts. We will help you analyse your gas, work out what the best solution is in terms of carbon selection, and give you the best performance and economy. So we'll start with one quick case study to answer the question, why use carbon at all to protect your engines? Well, our largest vessel, this 30 cube vessel, which is the largest vessel on the market currently, it was the very first vessel we developed was delivered to a landfill gas site in Scotland. This site previously had no engine protection at all, and they were changing their engine oil every 150 hours. So you can imagine the inconvenience and the cost of doing that. After we installed our 30 cube Vauxhall vessel, change out increased to every 1,000 hours. So obviously that gave them reduced downtime, reduced maintenance cost, reduced consumables in terms of oil. And the customer told us on that one site alone, it saved them £1 million a year in terms of process. So a huge saving that is achievable just by adding one of our single filters. Just a little bit more detail on our engineering before I talk about some more case studies. So in addition to the vessels, we can also supply all the pipework, the connections, etc. And we have an in-house design capability to do that. And it only adds typically 2 weeks to the lead time to a project. Essentially, we want to be the one-stop shop for carbon filtration for the full service. If you need carbon on your site, you can come to us and we will engineer the solution to it. An example is a wastewater treatment plant in central England. It did have a siloxane filter, but it was very, very small, less than 2 meter cube. That's actually smaller than our smallest mobile filter. So real tiny little thing, wasn't spec'd at all for the job. So they decided to go right up to our biggest filter, our 30 cube filter from day one. And as you can see from the drawings, we needed to engineer and install all the pipe working connections to allow access for the 30 cube filter. Obviously it goes in on an articulated truck. You can probably see in the picture behind me, I don't know if you can see that. So it needs space to get in. So in order to connect it through, it needed all that pipe work. And we did all that within 2 weeks. And future-proofing, so we can install pipework for multiple filters, even if a single filter is installed initially. So again, if a site wants to try a filter, but may need more in the future, if you engineer that right from day one, then it saves you time, effort, and cost further down the stream. So a second case study, so this is a biomethane site in the south of England. So again, I call this not enough carbon. So the main issue at this site was hydrogen sulfide. It had a little bit of VOC, but mainly H2S was the problem. They do have two small 6 cube fixed carbon filters installed by the original equipment manufacturer, but it was soon discovered that wasn't sufficient to cope with the H2S levels in their gas. They were changing their carbon out every 3 to 4 weeks, and that required downtime and cost, obviously. So we installed 2 of our large 30 cube filters, plus all the pipe work to connect it to the existing pipe work on site. You can see that on the top right hand side. The change out now is every 6 to 7 months. And the way we've done the pipe work is there's no downtime. So if you need to change one of the filters, you put the gas through the second filter and you can exchange the first filter and vice versa. So 0 downtime. The plant now works continuously. The customer reported a saving of about £100,000 per year from that installation. And now also they've got a CHP on site, as Julia mentioned in the introduction. Most sites have both. So they now have one of our small 2 cubic meter Voxorbers to protect the engine as well, as you can see at the bottom picture there. So again, nice success story, the big vessel and the small vessel, both on the same site. Another case study where they had no carbon at all initially. This is a very recent one. If you follow us on LinkedIn, you'll have seen some posts about this project in Scotland. Another landfill gas site where they had no filters. Main issue is, as in most cases, is siloxanes, but a little bit of H2S. So they installed one of our Voxorbers plus all the pipe work you can see there in the design. So that's our design for the pipe work. And now they expect to change out every 6 to 7 months. It's only just gone in the last 2 weeks, but that's the expectation. And again, reduce maintenance, downtime and consumables. And we're now looking at other sites for this customer too. So to summarise.
Oh, sorry. Perfect.
Yeah,
I just wanted to ask.
Yeah, that's it. Coming to the end now. Thanks, Julia.
Perfect.
So yeah, benefits of carbon filtration. You're protecting your engine. You can upgrade your biomethane with the same technology, and you can also use it for general odour management on site. Gives you reduced maintenance and downtime, and prolong the life of your expensive assets. Each situation is bespoke. Biogas is a witch's brew of different gases. So in terms of contaminants, flow rates, and process conditions, every case is different. So please talk to the experts, and we will help you solve your problem. So I hope that was interesting. Just a very quick run through. Please come and visit our exhibit booth. We have a team available to talk to you. And importantly, tomorrow afternoon, we have a breakout session where I'll go into much more detail about carbon selection, vessel selection. That's at 2 o'clock tomorrow, 2 o'clock UK time. So please, hope that was interesting, and thank you very much.